Good morning again. Today I'm going to give you a brief, I'll explain everything about the assignment on hepatic clearance. First, you have to go over the data. We have clearance in milliliter per minute, fraction no unit, bioavailability no unit. We have volume of distribution in liter, we have T-half in hour, and FUB is fraction unbound. I have not yet taught this. It is fraction unbound, means in the blood we have drug which could be bound to plasma protein, which will be called FUB, and unbound we do not have, is free drug. So we have bound drug and free drug. And also you have to see that blood flow, liver blood flow is in milliliter, it is in liter per minute. So all this is milliliter per minute, this is in liter, this is in hour, and this is in milliliter, this is in liter per minute. But if you look into the answer, all these are in milliliter per minute. Milliliter per minute. So I think first thing you may want to do, you convert this to 1500 milliliter per minute. Now we have to do the calculation step by step. As I have shown you in the class, we have to calculate first hepatic clearance. To calculate hepatic clearance, we have to use that equation of renal additivity of clearance. As I have mentioned, FNR plus FE is equal to 1. And I have mentioned many times, this NR could be FH. Mainly, most of the drugs are eliminated by either renal elimination or hepatic elimination or hepatic clearance. Again, so here we have FH plus FE is equal to 1, and FH would be 1 minus FE, which is going to be then 1 minus 0.187. This 0.187 comes from there. Okay, so now FH is equal to 0.1813. So your FH, or here's hepatic clearance, fraction hepatic clearance is 0. And we also know the equation for fraction hepatic clearance would be CLH divided by CL. Always you have to remember, it is, for example, if you are trying to calculate fraction in the urine, you put CLR divided by CL. Here we are asking for fraction hepatic, we put CLH divided by CL. So now we know we have to calculate CLH. So here this is asking for CLH in milliliter per minute. So your CLH is going to be FH times CL. FH, we know this is our FH. So this is our FH. So we'll put here FH 0.813 times CL. this is our CL 0, so it's going to be 177 milliliter per minute. So this would give you CLH is 1439.01 milliliter per minute. So these are the steps in case of, these are the steps to calculate hepatic clearance. So our hepatic clearance now, our hepatic clearance is 0.813. let's keep this. We may need this clearance to calculate hepatic clearance of a person with a bad liver. So this is our hepatic clearance. Now renal clearance. Renal clearance is easy. Renal clearance would be C this is this is our fraction hepatic clearance. Now our hepatic clearance is 1439.01 milliliter per minute. Hepatic clearance we can calculate many different ways. So renal clearance you can just do CLR is equal to, which is 0.187 times 770. So where do we get this? This is the fraction eliminated in the urine, and this is our total clearance. So your CLR is going to be 330.99 milliliter per minute. So this is one way of doing CLR. Another way, I think one of the students Omid was telling, just subtract. Yes, this is another option. CLR is you subtract your hepatic clearance from the total clearance, which is 1770 minus 1439.01, which is going to be also 330.99 milliliter per minute. So this is our renal clearance. So here is our renal clearance. This renal clearance is 332.99 milliliter per minute. Hepatic extraction ratio. We have to look into the one of the equation. Let's see if this equation is there. New equation sheet should be somewhere. Clearance additivity. Anyway, I have to look into the final equation sheet. Let's see, this one. Yes, here we have that equation, all the equation. This is our equation. So to calculate renal extraction, we do not have drag in, drag out. What we have E. So we have to calculate E, but what we have blood flow, and what we have renal hepatic clearance. So if you, this is the equation we have to use. Q is equal to E times CLH. So, and here is the equation we have to use. Let's come back, and then CLH is equal to, now we have to calculate E. E. To calculate E, we have to use the equation is what? Equation is CLH times QE. CLH is equal to QE. Now we are going to calculate E. So E is equal to Q by CLH, and our Q is equal to, I think, sorry, E is equal to CLH by Q. So our CLH is this one. This is our CLH, 1439.01 divided by Q is 1500 milliliter per minute, and our CLH is also milliliter per minute, and then our Q is going to be 0.959. So extraction ratio is 0.959. Sorry, I guess I have not yet eaten my lunch. I'm tired, so I'm making mistakes. Here, for this extraction ratio, as I have shown in the class, you have to use this equation. E is equal to CLH divided by Q. That this is the same equation, is CLH is equal to Q times E, and then you put those equation. E is equal to CLH by Q. Our CLH, we know this is the CLH, and then Q is from here. Just you have to convert to milliliter per minute. Then hepatic availability, and I have, in my previous video, I have mentioned hepatic availability is defined by this 1 minus F is first, it is denoted by F prime is equal to 1 minus E. That means fraction of the drug that escape the hepatic metabolism. So hepatic availability will be 1 minus our E is this one. This is our E. So it will be 0.959 here is equal to 0.041. Our hepatic availability is 0.041. And then in my previous video, I have explained what is gastrointestinal ability. The gastrointestinal ability is the fraction of the drug that escapes metabolism or degradation in the GI tract. And there is the relationship between F prime, between bioavailability, oral bioavailability is hepatic availability times GI availability. So again, this means hepatic availability fraction escaped by the liver, and this is fraction escaped from the liver. This is fraction escape degradation in the GI tract. So you use this equation to calculate GI availability. So to calculate GI availability, Fg is equal to F by F prime. Here is equal to 0.0299 divided by 0.041 is going to be 0.735. So this is our GI availability. This is our GI availability F 0.0735. As you can see, there is no unit. Here we don't have unit. In this clearance we have unit, renal clearance we have unit, extraction ratio no unit, hepatic availability no unit, extensional ability no unit. Now we have intrinsic clearance. Intrinsic clearance, and there are two terms: intrinsic clearance of the free drug, intrinsic clearance, overall intrinsic clearance. Intrinsic clearance, I have mentioned, is the innate ability of the drug or propensity of the drug to be metabolized by the liver, or liver's ability to metabolize the drug. And there are two terms. One is called intrinsic clearance of free drug. There are two terms in our note we have been using. It may be different. So the intrinsic clearance of free drug, which is noted by this prime Cl prime INT. Another term which is called hepatic intrinsic clearance. One is called hepatic intrinsic clearance, which is CLINT. I want you to remember this, that we are using two intrinsic clearance. One intrinsic clearance, we are saying hepatic intrinsic clearance of free drug. Another is called intrinsic clearance, hepatic intrinsic clearance. So there is a relationship between intrinsic clearance of free drug and intrinsic clearance, hepatic intrinsic clearance. First, to calculate hepatic intrinsic clearance, we have to use that equation. This is the equation we have to use. Ladies and gentlemen, this is the equation we have to use to calculate. Here in this equation sheet, so here the question is asking to calculate CLINT. This is hepatic intrinsic clearance. For this you have to do some manipulation, and equation is going to be like that. So what manipulation you have to do? If you do the manipulation, you have to calculate CLINT. You have to do this. CLINT is equal to E times Q divided by 1 minus E. If you do play with this, you will come up with this CLINT. So we will use this equation. As you can see, this format of this equation is not in the equation sheet. So you have to either you memorize this or just know how to manipulate this equation. So hepatic intrinsic clearance, we will use this equation. CLINT is equal to E times Q divided by 1 minus E. That means divided by 1 minus E. That means we will use E, we know 9.59 times Q, blood flow 1500 milliliter, 1 minus 0.959, which will give us a value of, this is going to give us a value of 35391.3 milliliter per minute. So this would be your hepatic intrinsic clearance. That means this is your hepatic intrinsic clearance, and this value is 35391.3 milliliter per minute. Now what is intrinsic clearance of free drug? Here is an equation we have to use for the intrinsic clearance of free drug. This is the equation. So here, intrinsic clearance of free drug, this as I have mentioned, CLINT is called hepatic intrinsic clearance, and intrinsic clearance of free drug is defined by this. Intrinsic clearance of free drug is CL prime INT is equal to CLINT divided by FUB, fraction unbound, or my fraction of free drug. So this equation we have to use to calculate intrinsic clearance of free drug. As if you go back to the, so we have this data here. We have this data. So we know the what is CLINT. So we just calculate CL prime INT is equal to CLINT divided by FUB, fraction unbound or fraction free drug. I think initially I said fraction bound, so this is fraction unbound, UB unbound. So here we use 35391.3 and fraction unbound is 0.83. This will give us intrinsic clearance of 42640.11 milliliter per minute. You see, this is a little smaller than our hepatic intrinsic clearance. So hepatic intrinsic clearance is, now intrinsic clearance of free drug is 4, so slightly bigger. So intrinsic of free drug is 42640 point 0.11 milliliter per minute. So this is going to be intrinsic clearance. As you see, this is 42,640 milliliter. Here it is 35,391 milliliter per minute. So that is a little bigger intrinsic clearance of free drug. Now, is the hepatic blood flow QNC the rate limiting step in the clearance of this drug? Yes. If you see here, hepatic extraction ratio is very high. So as extraction ratio is very high, when the extraction ratio is very high, that is the hepatic blood flow, which is Q, is the rate limiting step in hepatic clearance of this drug. I will explain this thing later, and also I have explained during in my preview video that high extraction ratio drug. I think let's go back to the preview video. You see here, low E drugs. See here, high extraction. Liver has an exception. This is that drugs with very high CLNT is much greater than Q and CLH of high drugs. So liver has an exception propensity to metabolize these drugs. So metabolizes all the drugs, entire drug, as it receives. For this disease cirrhosis, other factors can influence the blood flow. When high E drugs, that when you can control, blood flow will have some influence, a major influence in this case. For this reason, our answer is Q. Q is his answer. So in a few minutes I'll start the second part of this assignment.